Hello and welcome to the Analog Devices Precision Training video, which focuses on switch and multiplexer technology. This video is the first in the series. We will discuss the basic architecture and key specifications used to design CMOS switches and multiplexers. We will highlight the impact of these when designing such a switch and go through the associated trade-offs that must be considered when choosing for your design. Let us first take a look at the basic architecture of an ideal switch. It has zero on resistance, infinite off resistance, zero input leakage, zero time delay, and can easily handle large signal and common mode voltages. If we look at the implementation of such a switch using CMOS technology, some limitations will exist that impact achieving the criteria of an ideal switch. However, if we understand the limitations and how they apply to this architecture, they can be easily overcome. We will now take a look at a key specification of switches, or the on resistance. In an ideal switch, this should be zero. CMOS technology offers many benefits when used in switch architecture, which we will now discuss. Looking at a single-channel, single-pole, single-throw CMOS switch, which consists of an NMOS and PMOS transistors connected in parallel. Here, the respective drains and sources of the two transistors are tied together and become the switch terminals V-in and V-out, while the gates of the two transistors are driven by a simple driver circuit to control the on-off action of the switch. If we now look at the on resistance of the switch, which is plotted against the applied input voltage, it can be seen that the resistance of NMOS increases with positive voltage and the resistance of PMOS increases with negative voltage. Thus, the parallel combination of these two characteristics results in the well-known twin peak or bathtub characteristic. This results in a relatively consistent or-on specification over the full input signal range of the CMOS switch. If it is required that the overall resistance should be decreased further, then the way this is done is to change the size of the transistors themselves. Decreasing the resistance requires an increasing of the transistor size. One thing that should be noted here is that for switches where the on resistance is really low, these are more susceptible to parasitic effects such as leakage current and capacitance. This is one of the main trade-offs when designing analog CMOS switches, and is a very important factor to consider when choosing a switch for your design. The positioning and application of the switch in your design will determine whether you should select a low-resistance switch or a low-leakage and low-capacitance switch. Analog Devices has many switches available to meet low or on or low leakage and capacitance requirements. So please check out our website for more details.